Hello students. So now we start with a new chapter, trigonometry. And before I get deeper into this, let me give you the meaning of the word trigonometry. It starts with the three alphabets TRI, which is coming from the word triangle, and METRY, metry means the measurement of the three sides of the triangle. Okay. So what are we talking about? Which triangle are we talking about? We are talking about a right angled triangle, right? So the entire trigonometry is all about the right angled triangle and the measurement of its three sides. Now, if you can see in this diagram, ABC is a right angled triangle. If this angle is theta, okay, then the opposite side will be called perpendicular, and the AB will be called perpendicular, and the BC will be called base, and the third side will be called hypotenuse. Okay. Now, if you remember in the chapter Pythagoras theorem, we have already studied that in a right angled triangle, the Pythagoras theorem says AB square plus BC square is equal to AC square. I hope you will remember. We are going to use in trigonometry as well. But let's go back to trigonometry. And trigonometry, the most important thing are the 6 trigonometric ratios. And what are these 6 trigonometric ratios? Number one is sine theta. Okay. And what is sine theta? Sine theta is perpendicular upon hypotenuse. Perpendicular upon hypotenuse. Second is cos theta. Cos theta is base upon hypotenuse. All right. Where is the base? Base is this. Hypotenuse is this. So this is cos theta. What is third? Tan theta. Tan theta is perpendicular upon base. What is the fourth one? Fourth one is the inverse of sine theta. It is called cosec theta. So what is cosec theta? The inverse. Inverse means hypotenuse upon perpendicular, right? And fifth one is the inverse of cos theta, which is called sec theta. So sec theta is h upon b, hypotenuse upon base. And the last one, which is cot theta, is the inverse of tan theta, and hence this will become base upon perpendicular. Okay, the inverse of p upon b, cot theta becomes base upon perpendicular. All right, so now you may be finding it tough to remember all this. We should have our own way of remembering this. My way of understanding and remembering forever is that I write in the numerator P, B, P, and in the denominator H, H, B. And how I remember this, that I call this Pune, Bombay, Pune, and in the denominator, happy, happy birthday. So what is the first one? The first one is sine, P upon H. What is this middle one? Cos. And what is this last one? Tan. Okay, now you can see quickly. Tan theta is P upon B, this one. All right. Now, in below, just write the inverse one, cosec. This one will become sec, and the last one is cot. So what is the cosec theta? It is h upon p. Where is cosec theta? H upon p. So now it becomes so easy. Pune, Bombay, Pune, happy, happy birthday. If the moment you see any question of trigonometry, just write this in one corner of the paper and you will not make any mistake. All right, so continuing with the formulas. So we have just studied that sine theta is equal to 1 upon cosec theta, right? So sine theta can be replaced with 1 upon cosec theta, inverse of each other. And similarly, cosec theta is equal to 1 upon sine theta. Second one, cos theta is equal to 1 upon sec theta. And the third one, tan theta, is the inverse of or can be written as 1 upon cot theta. All right, simple three formulas which you can see and remember. All right, now another interesting thing what you will see here is that the first two, sine theta and cos theta, if I divide them, okay, so if I divide them, then what happens is sine theta upon cos theta, okay, becomes P upon H divided by B upon H, right? If you divide sine theta and cos theta, this becomes P upon H divided by B upon H. Now H gets cancelled, and what we get, P upon B. And what is P upon B? What is P upon B? P upon B is tan theta. So P upon B is tan theta. And so tan theta is equal to sine theta upon cos theta. This you need to remember. Tan theta is sine theta upon cos theta. And what is cot theta? Cot theta is the reverse of this, which is cos theta upon sine theta. I hope once you start doing the sums, all this will be easy to remember. Now, the last three set of formulas, again, very important ones. One of them is sine square theta plus cos square theta is equal to 1. Let me prove this, okay? So sine theta, you know it is perpendicular upon hypotenuse. So in this diagram, sine theta is AB upon AC whole square, okay? Plus, what is cos square theta? Cos square theta, now you know it is base upon hypotenuse. So what is base? BC upon hypotenuse, which is AC whole square. Now let's see. Squaring AB square upon AC square plus BC square upon AC square. Right? Now adding the numerator, because the denominator is same, I get AB square plus BC square is equal to upon AC square. Now, AB square plus BC square in the numerator. What should I write for this? AB square plus BC square. What should I write instead of this? I can write instead of this, AB square plus BC square is AC square. And AC square upon AC square is equal to 1. So remember the formula, sine square theta plus cos square theta is equal to 1. I just showed you the working of this, how we derive this, how is it equal to 1. But you have to just remember this formula, sine square theta plus cos square theta is equal to 1. Now there are two more, which I'm not going to go in detail. I'm just going to write down. 1 plus tan square theta is equal to sec square theta. Remember this. And the last one is 1 plus cot square theta is equal to cosec square theta. So these are the three formulas, 2 here, 1 here, 3 of them, plus remembering that tan theta is equal to sine theta upon cos theta, then remembering cot theta is the opposite of tan theta. You can see here cos theta upon sine theta. Now remembering these 6 trigonometric ratios through this way of remembering, I think then in that case, there is nothing more in trigonometry uh, which can, trouble you in solving the problems. So that's all, with the basics, the concepts. I'm sure if you know this, if you remember this, each and every question in the exercise can be solved. See you in the next one.